Hi, I'm Tom, welcome to Make and Mod. Today we're going to upgrade the power supply in this baby, the RigidBot 3D printer. The power supply that comes with the RigidBot, it's a fire hazard, it's loud, which I don't like, and also it's just way too big for a 400 watt power supply. So it's time to upgrade. Okay, so here I have the original RigidBot power supply. And I'm just going to take a look inside. Okay, so you can see it's pretty sparse components wise, apart from this one kind of control board here. It's got no brand caps, like there's literally not a brand written anywhere on them that I've been able to see. There's no real kind of this is all the thermal relief it has, which is reasonable, but it's not heaps. The insulation is actually coming off at the bottom here. I don't know if you can see that, and that could short out to something. Like it's been, obviously you need insulation off to solder it, but they've taken it too far back. Now this is the real atrocity. This is a nightmare. This is actually better than some other people. Some other people's are much, much worse than this. The other thing that really gets me out this wiring, apart from all the crappy solder, is all the lead distances. Like, I don't know if you can see this lead here, but that's almost touching that plane there because it's that long, and it's not meant to. You can clearly see it's been etched around there. Yet I could have a short across there. Same with components across here that are separate components, but the leads on them are so long they're almost touching another component. And I'm surprised that mine actually worked, but it did, and it did a reasonable job. But I don't feel comfortable with having this as my power supply, say when I leave the house to go do something, etc. Now, one thing you may want to salvage off here is your original Kikon power lead, like you've seen that I've done here. Now, this is what you want to watch for. When you're cutting off your Kikon power lead, take note of these symbols here. As far as we're aware, for the architecture of this power supply, these symbols are correct. So V plus is positive 24 volts and V minus is negative 24 volts. Notice here that V minus has red cables and V plus has black cables, which is the opposite of conventional red is positive. Some people have had green cables and blue cables and purple cables, and just take note of these symbols, and even then, double check it with a multimeter, which I'm going to show you how to do later in this video. The connector is the only thing I honestly think is worth salvaging from this power supply. Some people may want to salvage this to connect to their other power supply, but I don't really feel comfortable with these clover leaves. They're not rated as high as the IEC C14 that I'm using. So I'm going for that, and this whole power supply, apart from that cord, is going in the bin. Okay, this is the Meanwell NES 350-24 that I've picked up to replace my RigidBot power supply. Now it's 350 watts versus 400 watts, and that's because I'm running a regular RigidBot with a single extruder. If you're running dual extruders or a big RigidBot, I definitely recommend getting 400 watts or above. In my situation, this will be ample power. Now I've pulled out all the screws here so I can do a little bit of a teardown for you guys, just to show you the quality of this versus the rigid brick. There's all the components of the supply. Now, as you can see, it's very, very well laid out. It's got Capex on capacitors, which aren't so good, but it's got Rubicons for some of the nicer, more critical components. It's fused with ceramic fuse here. Just everything's nicely. It's got lots of strain relief and some nice thermal paste on these side contacts here, including a little temperature sensor just in here that measures the temperature and decides when to turn the fan on and off. If we want to just compare the soldering quality of this to the RigidBot, it's just amazing. Just some close-ups of those, of that soldering. Just look at how good that is. Also worth noting is the case has an insulating layer on the bottom here. Here's what I'm going to use to do this conversion. I've got an IEC C14 socket, which version I have is fused and switched, which in my opinion is the best way to do this, though you can do it with just the socket. I've also got a C13 cord to go with that. These are also known as like kettle cords or computer power supply cords, or but if you look up IEC C14 switched on eBay, you should be able to get one of these. These cords, I've got heaps of them laying around, but computer stores or, just home appliances, like I said, they come on old style kettles here in Australia. That's got an Australian power plug on the end, so I'm not making that cord, it just comes prefabbed like that. Now I've also got some hookup wire here. Now I'm doing it to Australian standards, and I suggest you do it to your own country's standards. So in Australia, we use the green and yellow for ground, the brown for active, and it's actually meant to be like a light blue for neutral, but I'm just going to use this kind of blue, standard blue here. It's close enough. Use the proper wiring standards for this. I cannot stress that enough. AC voltage is dangerous, and if you've got at least the proper colours and someone else comes along, they'll know what to do. Now, to go with this plug here, it has little 4.8mm terminals, so I've got some 4.8mm spade crimps that just slip over there. These are the non-insulated type, and they've just got a non-insulated end on the end there. So then to go with that, I've got a non-insulated crimper, which is a ratchet style crimper for crimping them together, and some heat shrink then to insulate them, but I just feel like you get a bit of grip when you use the non-insulated types. Some end cutters to cut the wires to length. You could use this to strip them, but I'm going to use these automatic wire strippers over here. The Meanwell supply I have uses a number 2 Phillips screwdriver, so that's pretty useful, and a lighter for shrinking the heat shrink. Now I've also got a soldering iron here, which while the crimps are effective on most of the connections, for some of the connections I'm just going to solder them, just for the kind of extra safety. So to hook it up, this is the earth and neutral here. I'm just going to send them both straight to the power supply. Now the active comes in here, goes through the fuse and comes out to this spade terminal here. And then I'm going to hook that to one side of the switch here, which is those two there. And they're both, they're not, these are two separate switch mechanisms. So they're not connected. So I'll hook two to there and then two to those two out to the power supply. And that way this switch has more current capacity than using both mechanisms. So, a bit of extra safety there. To start with, I'm just going to strip some of my active wire here to length. Now, you don't need much for these connectors. I'm just going to take the connector. Now, making sure some of my insulation is actually inside the crimp there. Just going to crimp that initially. There we have a nice, tightly crimped connection. That is just, see, it crimps both the insulation and the wire, and that is not going to fail. Now, I always test my connections with a light tug, and I think, oh, that might make the connector come off. Well, that's the point. If it comes off that easily, you're probably in trouble. Now, straight away, I'm just going to shrink that heat shrink there. So I'm actually going to put a couple of different sizes on, just to make sure it's got adequate coverage. For the connection of this output to the switch, I need kind of 3 spades in line. So I'm going to do that by having 2 spades like that and then a center one joined here. And to do that, I'm just going to twist these wires together, put a crimp on them, and then I'm going to solder it just to make sure it's extra secure because there's such a fat kind of bit of connection within the wires. Now I'm going to hook up my wires to the switch here. So the blue, which is neutral here in Australia, is going to go to the neutral wire there. The green and yellow, which is earth, is going to go to the earth one there. Now, this one here is active to there, but I'm actually going to put it on either side of the switch first. And then this here, it's going to be pushed onto the active on the other side of the switch. I'm going to put these two here. And there's my output wire there. Now, let's hook it up to the power supply. So to hook up the power supply, the active side is live, that stands for live, neutral, ground. So for me, that one will be the brown, that will be the blue, and that will be the green and yellow, according to my country's wiring standards. Now I'm just going to bring them up from underneath here into the terminals. So to connect to the rigid board, I use the original cable that we saved earlier. Now this doesn't make a very secure connection to my rigid board. So another option I have is I could just solder directly to the board with these. Or, here I've sourced a 4-pin power mini DIN Kicon connector kit, and they come as a amount of parts that you assemble to make the connector, and I've assembled one of these already. And once they're assembled, you can't really take them apart, but I've tested it in my RigidBot and it makes a super secure fit. So that is the way I'm going to go. In the kit, it comes with this little bit here, and that's just got 4 little solder cups in it, which I can solder into. And so I've got some 15 amp cable here, which for my 14.6 amp power supply is going to be more than adequate. Now I've actually split this cable here because there's no way I'm going to get like full 14 gauge cable into those tiny little solder cups. So I'm just using one bit of 15 amp cable, like 15 amps each line, and I'm going to split them, put them in the solder cups and solder them up. So holding the connector like this, negative is the left 2 pins and positive is these right 2 pins here. So just going to put the red on the right 2 and the white on the left 2. So the first way I'm going to attempt this is by filling one of the cups with solder, trying to insert the cable into the hot cup. Then I'm just going to solder the other side. That's securely soldered enough. It's not the best job in the world, but it's all the best I'm going to get in these fiddly little connectors. Okay, now that I've done that, I'm just going to put some electrical tape between the positive and negative side. Hopefully that stops any chance of those two shorting out together. Now here's all the bits that came with the kit, just here, and firstly I'm going to take this cable clamp here, clamp it over them. At the end of the cable here, I'm just going to put my small strain relief section into the rear half of the connector, and then just work that in there. Just slip that through the cable. Just going to slip that back. Now on this other end of the cable here, I'm going to put the spring, then the relief mechanism. If you just align the 2 sides there, should slip over there. Looking at our other Kicon connector, you can see the bump goes at the bottom and the 2 close together pins go at the top. So I'm just going to slide that in through there. And that kind of made a bit of a clicking sound as it popped into place. So then I'm going to come up with this. So either side of this into the connector. And take this back half here. And clip that over the whole assembly. Then you're going to slide the spring up over the whole thing. I'm going to slide this part up with these 2 little knobbly bits facing away from where I am at the moment. Slide it up over here. Clamp it in place, but it can take a fair bit of effort. To finally complete it, slip this over like so. And then just get it to click in to the back half. And there you have your assembled connector. Once you've done this, pull back the sleeve on your Kicon connector, push it in, like so, and then you let the sleeve drop back in place. I think you'll find it's very securely attached, like it won't come out unless you pull that sleeve back again. Now I need a case to case all this stuff up, so here's the evolution of design for my cases. First off, we have case V1. It's printed in black ABS, it actually had a fair bit of warping on it. It's too long. Case V2. First thing I did, add banana plugs. It could be good for voltage checking and connecting accessories like LED strips and, you know, other, maybe an octopi or something like that. Now this version of the case is now shortened. Okay, so it's designed to have the RigidBot power cord just slide into there. That's why it's in 2 halves. And then some M4 screws go in the top here, M4 nuts in the bottom. 2 halves slide together, and you screw it all in. And then it's got some nice screw holes inside that hold it to the supply, and that's very neat. Then I decided that I really didn't like this RigidBot cord. It's just not for me. I don't feel it has very good strength, and also I wanted to put the supply inside my RigidBot, and it didn't have enough flexibility to really allow me to do that. And that's when version 3 came along. So version 3 is printed in clear ABS. Now in this one you'll notice it doesn't have the slot for the RigidBot power connector. Now I could have printed this in one piece technically because I didn't need to slot the power connector in, but I still wanted some strain relief for my new cable, so I decided to keep it in 2 halves, and then this is actually pinches on the cable to act as strain relief. I want to run this around straight back into the RigidBot so I can run the power supply internally. So I'm just going to drill a hole just there, come through here and end about here. So I need about that much, and then strip that. Oops. Now I'm just going to screw these into here. Now to prep the bottom half of the case, I've just inserted these nuts here, which involve putting an M4 screw into them because they're M4 nuts, and just working them down into that half, the relevant half that they belong to. Okay, now I'm just going to solder the wires onto their respective connectors. Now I've got those soldered up, I'm just going to heat shrink them. Okay, now that I have those there, I'm just going to cut the wires to length so I can bring them down to these 2 points here. Now just to finish up here, just going to slide the box over, screw the bottom half of the box in. Again, be careful screwing this in, as these are screws straight into the aluminium. On my Meanwhile supply they are, and they do strip. I've stripped out 2 of them and had to change them to M5s from M4 threads. Just going to sink that in there. Put a bit of cable relief on there. And tighten that down. And there you have it, a fully assembled and ready to go power supply. So I'm just going to run a few tests before I actually attach it to my bot. Firstly, I'm going to take my AC cord here, now it's plugged in at the wall, just very carefully. You know, touching the plastic, not the metal casing. In case I've wired something up wrong, like an active to an earth would make that casing live. So very carefully plug this in. Nothing's happened so far, so that's a good sign, you know, not electrocuted. And then just looking in the side here, just going to flick it on, and then as you can see, now a green light on in there, which means it is functioning as it should. Now I'm going to take my multimeter in voltage mode and check that these are how they should be. And that is almost dead on 24 volts, that's good enough for me. Now there's a little adjustment screw inside for adjusting this, so you may need to pop off the top of the case and adjust it. Just be very careful playing around near AC voltage. Personally, you know, I try not to take the risk. Now I'm going to take my connector and holding it this way up with the wider space at the bottom and the smaller space at the top, just the same way the original was spaced. Negative is on the left. Now I'm just going to jam this probe out here in here, touching the casing, but it means on the other side I cannot touch the casing with the probe, or else I'm going to have a short and a big spark. So I'm actually not going to look at the multimeter. I'm just going to touch there and it should say positive 24 volts. I'm comfortable with plugging this into my RigidBot, and that should work. Now the plan is to actually mount this underneath my RigidBot. So I developed this custom bracket on the end of the power supply here. Now it just screws into some of the mounting screws on the bottom there. They were the easiest accessible, and I've just got this spare aluminium tube, and this just can slip through there like so, and that's just going to support the rear of it. And then to support that against the side of the case, I just have these little parts here. They clip over the tubing and slip onto the tube. So I'm going to be installing my power supply just up in here like this, which means I have to move a few of these cables around. Now let's get this in. Just so I have a good position for it. So then I can do this and just draw a line around the supply. Now there's the, I don't know if you can see it, the lines I drew out in the back. Now I'm not going to cut out the full profile, just enough for that power switch area. So there's the finished product. Let me just say, I'm glad this is on the back. It does not cut very well. Definitely use like a Dremel or maybe a jigsaw or something. I just did whatever was easiest. Now I also had to expand this hole out over here so I can slip my little ferrite core through from the inside. So I just printed out these two brackets here, which just sit on top and make that nice and firm so I can switch it on and off without it falling back. See, it's quite secure in there. Well, in my opinion, it's enough to shake the whole table. And now I've just been cleaning up those few wires that I freed up before, and I'll be done. Power supply is upgraded. There it is, fully installed. Back cover back on. Gonna take my plug here, plug her in there. Then to turn it on, I turn it on at AC first. Then at the DC over here. Flashes twice, everything's started. The fan's not running because I've unplugged it for filming. And there we go, a fully upgraded power supply. See, now with that cable tucked in just there, I can put this almost flat against the wall, apart from that little bit of distance it needs for the bed. And there's no bulky power supply hanging out anywhere. Thanks for watching, everyone. Don't forget to subscribe. See you next time. Check out my other videos. Don't forget to subscribe.